Welcome to the sixth section of the course. The subject in this section is microservices and reactive microservices even. We will begin by describing microservices and their cases, advantages and disadvantages. We will then move forward to studying the main concepts behind reactive microservices that are reactivity and isolation. In the core of the microservices technology is divide and conquer. You could claim that this saying applies to all programming in general, but it's one thing to apply it in the construction of classes, modules, or even methods, and then another one to apply it to splitting a monolithic application into several projects called microservices. You're going to hear this saying a lot in the microservices world, splitting the monolith. This is the objective of the microservices approach. But what is a monolith? What does really constitute a monolithic application? If you have ever developed a web application or an API, most likely you have created a monolith. Monoliths are single-tier applications where most or all of your app's logic resides in a single unit or module. Internal modularity may exist. For example, you may have or use libraries, controllers, and packages, but everything is grouped under a single project with a single database and usually a single cache module. Sometimes your monolith may include the presentation layer if we're talking about traditional MVC applications. Modern apps separate the presentation layer into either a form of a single page application or a mobile app, but if all of your backend resources are still part of a single project, a single API, most likely your application is still considered to be a monolith. A monolithic application usually looks like this: a huge collection of models and an equally or maybe even more huge collection of controllers, all in the same project. They constitute an API, and of course, there are various clients that use that API. You may have a single page app, mobile and desktop applications, partner services, old libraries, legacy libraries, tools, and so forth. This is the way most applications are built and were built until now. This design has the following advantages. First, it's very easy to write an application like that. When everything is part of the same project, you have great reusability. With a little bit of effort, you can manage to follow all the best practices and patterns like normalizing your database, using foreign keys and all. It can also produce fast results. You can quickly set up your MVP and get to production fast. For small teams like startups, this is vital. Add to that the fact that you can find extremely cheap hosting for monolithic applications, and it's no wonder why most teams start their projects as monoliths. But in the long run, those monoliths will probably hit the wall. They cannot continue to have the same level of growth forever. They start facing scaling issues. Some of their internal components are tightly coupled, so change in one part of the codebase may break something seemingly unrelated in another part of the code. Maintenance becomes hard, and adding new features can be a slow and risky process. Also, with a monolithic approach, you're also tightly coupled with the technology stack of yours. If, for example, you decided at the beginning of the project to use .NET Core or Java, you will be forced to stay with it till the end. So if a third-party API does not have an official .NET or Java library, you will be forced to write it yourself. If you want to communicate with a MongoDB, for example, you know that Node.js is the perfect candidate, but you can't use it because it cannot be integrated to the codebase without issues. And finally, what is most likely the most important downside: slow performance. Most monoliths are built with a one-size-fits-all framework. Such frameworks try to cater to most developer needs without specialization, and this means using tons of unnecessary middleware and libraries, unnecessary checks, and more stuff that can hinder your app's performance. This is in fact the most common reason why teams decide to rewrite their projects using the microservices approach. Let's dig a little bit deeper into a monolithic API. This is what the API we have been building in this course could end up looking like. Some models along with some controllers, each doing its own job, having a single responsibility. But they are not all equally used. Users don't change their settings all the time, so the settings controller may not be very busy. But the orders controller is definitely the biggest. So what happens when we need to scale this? The most common scaling technique is to scale horizontally, by spawning more instances of the same API. Let's say we create 3 more instances. There are many ways to optimize the scaling mode, like using Docker and Docker Swarm, with services that provide auto-scaling capabilities like Heroku or Azure App Service. But there's a fundamental issue with the scaling model that resides at the core of the monolithic approach. The problem is that not all parts of an application need to be scaled the same. Remember the previous example? The orders controller and all the components it makes use of are in great need of scale. So you end up either scaling less than you truly need to save money, but risk having. This is how our app can look like in a microservices approach. We split the models, their controllers and services into separate projects that can scale independently. We may determine that the optimal number of instances for the authentication microservice is 2. For the subscriptions microservice, the optimal number of instances is 4, and for the busy orders service, the number can be 16. And this is how you can achieve optimal scale and end up having low cost and high availability at the same time. So, microservices excel where monoliths fail, primarily in their ability to be developed, deployed, and scaled independently. Microservices are by their nature isolated, but in order for them to be classified as reactive, they also have to comply to 2 following fundamental rules. A microservice is reactive when it is stateless, and .NET Core with Service Fabric allows us to build stateless microservices. They should also not share state by, for example, using a shared database. Each microservice should own its domain and data, and they should asynchronously communicate with each other without one microservice blocking another one to retrieve or store information. An example of an architecture that can be considered microservices oriented but not reactive is this setup. We have 4 microservices that communicate via the same database. This is not reactive because microservices are not isolated. This, however, is a reactive approach. Each microservice owns its bounded context. The authentication service is the only one connecting to the authentication database, which happens to be implemented with SQL Server. The orders service only connects to the orders database, which happens to be implemented in MySQL. The subscription service is the only one that connects to the subscriptions Cassandra database. Every other service that needs to access information about the subscription has to asynchronously go through the subscriptions microservice. Finally, the settings microservice connects to an isolated settings database microservice. Any attempt from a service to access the domain of another service is directly and strictly prohibited. This last rule that reactive microservices must comply with is the no sharing rule. According to this rule, no assemblies, libraries, or modules can be shared between microservices. So what we did in the project so far, creating a common class library and dynamically linking it to our projects, violates the no sharing rule. So no reactive microservices until we fix that.